Hi, in this video, we're going to discuss about anti-reflection coating and more technologies uh, for lithography. First, we're going to discuss about the anti-reflection coating. If we put the photoresist on the silicon, if the light goes through the photoresist and because the silicon likes to but as you can see, the silicon shines with the reflection of the light. With the reflection of the light, with with some like technical issues, if the original light and the reflected light is constructively is constructively interfered, the the light these these tend to be overdosed for the light, and if the reflected light is destructively interfered, the amount of light exposure if the exposure of light uh is less than we want. For these reasons, the anti-reflection coating technology is especially is more important, especially for the modern devices. As you can see, this is an example for FinFET structure. With the as you can see this wave-like pattern on the side of the fin. This is because This is because of the reflection of the constructive and destructive reflection. This is especially bad for modern devices because it is this 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 wave-like structure can cause the defect or the change of the technological issues. To deal with this, we put the anti-reflection coating on the top of the on the top on the above of the photoresist or on the bottom of the resist. Because the anti-reflection coating tends to be polymer with the for top ARC or bottom organ ARC. Because the photoresist also is made of polymer, uh, chemically they can be chemically worked to make them even more defect. So for modern technologies, most anti-reflection coating are used in bottom ARC with inorganic materials. On the silicon surface, we put the inorganic anti-reflection coating right above the silicon, and we put the photoresist on the anti-reflection coating. Moreover, for this dense pattern, if the light goes through the pattern, the light tends to scatter. In the center of this pattern, the unwanted exposure can make the pattern to destroy. So if it so we put uh, this material that if the light goes through one material, the distance that light goes can change the phase that enters to if it exits to the system. So if we change the phase for half in this phase shift, if for the interfered area, because the sum of the uh, phase shifted light for the phase shifted light are destructively interfered, the pattern can be drawn even better than for the conventional photo masks. This can be done by putting some materials on one pattern or cutting through for half the face pattern inside. This is called the phase shift mask. Moreover, if we make the pattern for photo mask, because of the interference of the actual pattern can be destroyed due to the priority of the photons. With this, uh, to deal with this pattern, we use computer devices to calculate how the lights can be uh, constructively or destructively scattered. So with these computers, we make the optically correct the photomask image. Moreover, if we put when the light goes through a slit, the light tends to scatter. So the first, the second light can be scattered like this wave-like pattern. If we put the light off axis, we can put even more light, like zero, first, second, third, like this. So we can put even more light if we put the light off axis. This is called the off axis illumination technique. With this, uh, we put the light to the photomask off axis and we put another mask under the photomask with the dipole or quadrupole pattern. We we again we again the uh take the scatter line up to concentrate again, and because the because for the higher orders the angle that enters the photomask is even shallower than the on axis illumination, so the depth of focus can be increased by this technique. Let's move on to the double patterning process. To make even finer pattern, we sometimes make the pattern with several times. Uh, on the left side, this is called litho etch technology. That means we make a lithography on the, for example, for the first, third, fifth, and so on, the pattern, and we make another lithography again for the second, fourth, fifth, like that. One another technology for this double patterning is self-aligned technique. I'm going to tell about this later. First, let's talk about the litho etch technology. These two approaches are basically similar because they all means that we first make a lithography and etch through to make first pattern and make and realign the photomask on the we realign the photomask and make an etch or deposition again. For that reason, in short, we can make even finer images. However, for this technology, if we make the lithography more, the more the time for lithography, it tends to be off axis uh, or the misalignment for because of the misalignment can be easily made. So the length of the pattern uh, can be can be destroyed from what we want. This is called overlay issue. Even 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 if it moreover because the structure that because the structure that fins are that 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 blocks up to fin not to move is removed, that even the fins itself or the structures itself can be destroyed with the power with the moving power inside the silicon. One another way to make the fine pattern is self-aligned double pattern process. We first make a lithography for first. This is called the mandrel or dummy pattern, and we put the spacer for we put and we put spacer for always the same thickness for to make these like pattern, and we cut the height for same like this thick for this thickness, and etch we remove the mandrel or hard mask. The final pattern is left like the final pattern is left like this, and we can make even uh, finer pattern. This technique is widely used until now for make the 10 nanometer to make sub 10 nanometer FinFET technology. Even though this pattern is even more easier than the LELE technology, even though the while we cut through while we remove the mandrel, the spacer or the hard mask itself can be destroyed for a little. They they make the overlay like error is can be made, and this is called the pitch walking error. Uh, Thank you for listening.